Thank you, Scott. Thanks everyone for coming. This is Xin from Microsoft. Together with me, I have Guohan. He's a dev manager in Microsoft. Today we are going to talk about SAI. I'm going to give a brief update on what's happening in the last year. Then I will give time to Guohan, actually looking forward where SAI is going, particularly looking at the speed, how fast we need to innovate, how fast we need to go, how flexible, particularly these APIs, people demand it to be flexible, or where can we go on this route? I will leave time for Guohan to share some of the thoughts looking forward. So for the ones who are new to Sonic and SAI, basically SAI is an abstraction layer. Try to make the ASIC underneath talking the same language to the software on top of it. Before, we have different type of ASICs, which is the brain of the switch. They all use their own dialect to talk to the software, so the software has to develop differently if I change your ASIC. So the mission of SAI is very, very simple, that on the management software, we would like to have one set of software that can manage different hardware. And I don't want to reinvest the software development if I have to switch different ASIC, or the ASIC has been evolving from different capabilities to the other. So this is the SAI. Then SAI come into being that we define a standard APIs that as long as the vendor SDK is able to comply to this API, the software developed, control software developed on top of it can stay the same. So in this way, it showed the complicated logic of the ASIC behind, so that the user and the cloud provider can focus their mind on the scenarios development and application development. So the community has been growing. That we have before there's like all the major ASIC. I can say all the major ASIC vendors are supporting SAI. And since last OCP summit, Cisco and Innovium joined the SAI community to provide the SAI support on top of their ASICs. Also wanted to call out that there are multiple North switch and OS are also built on top of SAI. Sonic, OPX, OS10, MetaSwitch, CONS, as well as the latest DNOS, which is open source software from AT&T. They're also looking at SAI, how to use SAI to support DNOS. So again, the community has been growing. Velocity actually is one of the things we are looking to, because from the community side, we have end user, we have ASIC vendors. That from the end user, we want to evolve as fast as possible, to take the features, to have the standard defined as soon as possible, without waiting for years to come into one agreement. So I have several data for you to show that how quickly we are evolving and changing. So from the organization point of view, that's how individual companies support SAI and take part into SAI community conversations, that it changes from single digit to like 13 major chip vendors are all in the community, in the organization working on SAI. Second, from the commit point of view, that's when we check in code, checking changes, checking proposals, that it starts with around 97 per year. The last year it was, in 2017, it was 400 commits per year. Now it's 700 commits per year. Proposals also, each proposal, we call a proposal is a feature, is a protocol. By supporting these proposals, we enable capabilities inside. It also grow quite fast during the last year. So basically, we are releasing at least 3 SAI APIs, SAI releases per year. At this moment, we are at SAI 1.3 release. Okay, just a very brief recap of what happened last year before we already have the basic L2, L3 functionality built up. In the last year, we have these few, 13 protocols, features enabled since last March. In the monitoring part, Guohan lead the proposal of telemetry and monitoring. Marwell did microburst enhancement for monitoring. Microsoft was driven this critical resource monitoring, enabled application software to peek into the capability of the ASIC, so that we know that when it's getting close to the TCAM size, so table size, that we will be able to alert and to react to these issues. I will be very fast. Then the protocol side, we have Manonog, Stell, Kevin, and Microsoft again. So these are all the capabilities and protocols enabled since last summit, and thanks for all the companies driving this change, making it standardized, so the application built on top of it is able to benefit. So the next step, I'm going to give time to Guohan to talk about few challenges that we see.
Yeah. We discussed in the SAI community, so I think here are 2 major challenges for the current SAI. We can always add new protocols and to the SAI to support new networking protocols, forwarding capabilities. Those, I think, we did a lot of proposals in the last few years. But still there are 2 major challenges. So one challenge is that we need a way to expose the capabilities to the applications, because we have to recognize, although the SAI is a common language for different ASICs, but still different ASICs have different capabilities. And now the SAI supports 8 ASIC vendors. So when North comes to the SAI, so basically they want to use the SAI to control different ASICs, but basically they want to ask a question to the SAI that, how do we know that, for this particular ASICs, what kind of a capability it has, and then he can enable the corresponding feature for the NOS. So in this case, application is also dynamic, because the application need to query the SAI capabilities, and then based on the query, he can expose different capabilities to the user. Later, I will give a detailed example on what exactly the case. The second one challenges, so we see that the SAI now is for the common functionalities, layer 2, layer 3 functions. So that is working really good. However, there is a growing need that using the SAI for some specialized functionality, which is not commonly used. For us, we have analyzing our protocols in our data center, using also in the WAN. Most of the forwarding functions is still using the traditional layer 2, layer 3 forwarding functions. The SAI can cover well on those areas. However, if we move into some SDN features, which is about overlays, I think Dave mentioned in his Sonic talk that we do need some specialized forwarding functions. So in this case, we need to allow user to customize the SAI pipeline and be able to ask the SAI to expose the programmable APIs so that application can use it. So let me talk about the first challenges. So as I said, the application need to query the capability and adapt its behavior on the site capability. So for example, let me give a simple example. So if we want to implement echo with a port range capability, basically in a command line, we can say permit TCP any, then 1024 to 1048. So that is a port range that this echo need to match, and then to permit those packets. So, when a node exposes this feature to the user, he actually needs to call the site functions to configure the ASIC to enable this. So he basically need to ask one question: whether the ASIC has the port range checker, which is a hardware feature in the ASIC, whether the ASIC has that, or whether the site exposed that feature on this particular ASIC. If yes, then the answer is that, with SAI, we already define a port range checker object. You can create that object, and then you can configure the object to match certain range. That's it. But if the ASIC doesn't have that port range checker, or if the site haven't exposed that port range checker through the site, then application basically, if he still wants to implement this feature, he can use other ways to implement the feature. For example, he can use multiple parallel ASIC rule using the bitmap to still map the range of the ports. So this is the basic question the application need to ask the site first, whether you have this port range checker or not. This might seem a challenging task because the ASIC has many different capabilities. However, when it comes to the SAI, actually surprisingly easy. Is because remember, when we develop the SAI, we always say, SAI is composed of object and attributes. So you have many different objects, and each object has many different attributes. So in terms of this case, we just developed two APIs in the SAI. One is to query the attributes, query a certain attribute for an object. And the second is to query a particular enum number that is supported by this particular attribute of a particular object. So these two query, which has been incorporated into the SAI 1.3, can actually answer the first question we asked. So in this case, the echo ranger, for example, if the first application need to ask whether the echo ranger is there or not. So he need to use the first API to query. There is a echo range type. So this object type is echo range, and then in the echo range attribute there is a type. So he need to query. He first query whether this attribute is implemented or not. Then the SAI will answer whether this attribute is implemented. If it's implemented, he will ask a second question to say, because there are different types of echo ranger. There can be source port echo ranger or destination port echo ranger. In this case, he needs to use a second API to query the enums that is supported by this attribute. Then he queries the enum and then gets the enum that's supported by the SAI, and then he can do the rest. If it's supported, he just creates that echo ranger. If it's not supported, then he will use other ways he will figure out other ways to implement that feature. So when the further beyond that, because the SAI has a lot of currently have a lot of object and attribute. So I think we need a better way to allow each SAI implementations to easily implement these query capabilities. So throughout I think the last year, we have Microsoft have developed a SAI metadata infrastructure, which allowed the user to add comments in the SAI header files, and then we have a set of a program to translate those comments into this metadata information. So on the left side, you will have, for this particular attribute, SAI root entry attribute next hop ID, you will have a different metadata information. For example, for example, what type it is, and then what flag it supports, and what kind of object ID, all the kind of objects you can input into this for this attribute. And then the tool will read this information and translate into this metadata infrastructure, which you can see it's like a C language infrastructure. And then it generates a C file that includes all this data. And then in your program, you can have a program to just include this C file. Then you have all the metadata informations you can manipulate about it. So we have some libraries using those metadata information to check the user input valid. So so down the road, I think we can also add some the vendor-specific information, like whether this attribute is implemented or not. Then each vendor can go and in their header files, because it's not touching the real header file, it's touching the header file comments. So you can add some comments into, you can add some metadata into the comments, and using the same infrastructure, we can build the metadata information, and then they can use this metadata information to hook up with a query function, so that for each attribute, they can easily implement those query capabilities for their site. So that's how we plan to address the first challenges to query the capabilities for the SAI. And then for the second challenges, I think, let me just step a little back and say the SAI is good for the common functionalities. We define the common APIs, define also the packet pipeline model, and each ASIC just map their SAI APIs into SDK-based into their SDK based on the SAI behavior model. For example, in this case, we define the behavior model. In the layer 3 forwarding case, we define a forwarding model where you first look up the layer 3 LPM table and then find out the neighbor entry, and then using the MAC table to find out the port. However, in the actual ASIC pipeline, it may be different. It may not have the neighbor table or MAC table, but in this case, the SAI between this behavior model and pipeline will translate all the information supplied by the user to configure each of the SAI table into their own ASIC table. So that's what the SAI implementation does for each vendor. So this is working really good. However, for the specialized functionalities, you can always try to define a new SAI attribute and then provide the implementation for the new SAI attribute to map to your ASIC specialized functions. That will be good. But in this case, you need to either work with the vendor directly, with the SAI provider directly, in order to get that function done. So we think that there might be another approach to use provide a SAI Flex API generated by the pipeline description language on top of the existing SAI behavior model. What does benefits to the user is that all the existing SAI APIs are still available, but user can customize their pipeline and use the generated SAI APIs. Here is the architect framework that we can provide this to the user. I will leave the details to the both sessions so we can go further to discuss all the details there. So imagine that the user writes this sample pipeline in any description language. It can be P4, it can be some other pipeline description languages provided by your ASIC vendor. And the ASIC vendor also provides you a compiler which compiles this pipeline and then inject this pipeline into the SAI behavior model, which means that the pipeline has these special functionalities. And then, meanwhile, the compiler also generates a SAI Flex API, which defines the object and attributes that user can control, and then expose that API through the SAI, and then, on top of that, the application can, using the Flex APIs to control that special logics that they add to the pipeline. So here, I'm not going to go to the details because I know that there will be sessions to talk about the details on some specific ASIC implementations. We can discuss that later. So that's the two challenges I think with SAI community facing and how we're going to try to address it coming down the road. Yeah. Thank you.
Very quick, just calling out that tomorrow we will have the SAI Sonic Workshop hosted by Linking. What we are going to talk about is looking forward, where is SAI going? Programmability, telemetry, WAN, support, protocols to support WAN, and testability are all on the agenda that we would like to develop more on these routes. Also, the last one is, this is the workshop information, the community call for participation. Welcome everyone to join us. All the centers are on the GitHub. We have the mailing list. We have the meeting every Thursday morning open to everyone. Thank you.
So we have time for questions for Xin and Guohan. If you have SAI questions, anything that was presented, go ahead.
Hey, Guohan. Actually, for the SAI capability, right? I know there's like a list of attributes which we can query for whether the ASIC supports this attribute. But can we also query the scale number this ASIC supports? Like, let's say this many ACLs it can support so that it can error out in the OS itself instead of coming down to SDK and then erroring out.
Yeah, so I think, the question is, apart from the capabilities, can we also create the resource limits, right? Yes, I think currently, I think the SAI already have some switch level attribute or some object level attribute to query some specific resources. For those for the route tables, the next hop tables, those already have some attribute. But in general, I think for the resources, we need to have a, currently we don't have a common API to query that like the capabilities, but we do have some specialized attributes that you can query for those. For that, if there's a new resource coming, we can think about whether we have generic APIs to do that, or we still go into the traditional route to add the specialized attribute to query that.
Okay. That's critical resource monitoring proposal, which has been published. But we are keeping developing that, particularly from the user point of view. What we have always seen, the common failures, what are the most issues that we have seen, that we will add it to the capability.
So the critical resource monitoring, it's part of SAI spec only, is it? Or is it?
Correct.
SAI?
Correct.
Okay.
Yeah.
Okay, thanks.
Others? I actually have a question. So in your example of the ACL range, you gave an example that said that sometimes the ASIC will have the capability to do a range check and sometimes it doesn't. And if it doesn't, then the application has to be aware of that and split the ACL into multiple entries. So why was that decided as opposed to pushing that into the adapter host and making, or whatever they call the ASIC piece, and making them always support a range, and if they can't support a range, then they have to split out multiple ACLs?
Yes, I think that can be done either way. If the SAI, the ASIC hardware doesn't support the ring checker, the SAI can also use the same trick that does the same thing, right? I think that is the example. It can be done either way. I think both approaches are okay, but I think as a SAI, in terms of providing the application, the capability queries, this is just one case. There are many other cases that if the ASIC doesn't have the capabilities, it's very difficult for the SAI to add that. For example, if it doesn't have the tunnel capabilities, if every packet has to go to a software to do the tunnel, that may not be. So still, I think having that capabilities as generic solutions for application to adapt its behavior.
Yeah, so I wasn't really questioning whether you need capabilities or not. It was just that one specific example. It seemed like it would be better for the ASICs that do support a range, they just do it, and the ones that don't get a little extra burden, and then the applications don't really care whether they can or can't natively support it. They just say, do a range.
Yeah, so I think that is, I agree with you. First, I think I agree with you. I just want to add that the counter argument is that they want to keep the size simple, and then because the scheme to translate the power ranging into multiple echo is really independent of the ASIC implementations, right? So you use a bitmap to do those mappings. It's a generic algorithm, so they can say, okay, I don't suppose your application, it should be able to do a generic implementations that are agnostic to different ASICs. That still, your application would be, work on multiple ASICs.
Other questions?
So you mentioned about the metadata that is being generated that helps the applications get information about what's there in the ASIC. Are you doing anything to make the people who are implementing the SAI API, their life easier? One of the difficulty that I've seen is, every single attribute you need to have a function implemented and have return the value. Can we have a static array or something like that where we just compile that information and then SAI can just pull it?
Yeah, so actually, so in our Sonic stack, we have called the SAI Redis implementation, which provides the same SAI APIs, and that Redis implementation leverages metadata to do all the valid checking. Like it do all the input checks, input parameter checks, leveraging this metadata. And that code is available, I think, in the SAI Redis repositories. If you can look at maybe some of them you can leverage, you don't have to do all the, it does more than the parameter checkings. It does something like correlating whether checking the object exists or not, because when you try to do reference object, you need to make sure that other object exists. It does something like for those checkings. I think that is actually common to all the SAI implementations. So we make that code available, but if you can also take a look and see, whether you can adopt that in your SAI implementations, that would be great. So if there's any feedback that we need to add to the infrastructure for you to easily adopt, I think we'll take that feedback.
I'll go check the GitHub for any documentation you have on that.
Okay.
Sort of to follow on and expand on that, all the attributes, as I've seen in SAI, are pretty much atomic. They're integers or booleans or whatever. And there's really not a structure concept, especially for the read-only data. It would be nice to be able to issue one request and get a whole bunch of data back, as opposed to like the individual functions for each piece of data in the structure.
Yeah. So maybe I didn't quite. Maybe let me explain a little bit. So I think there are some data that read-only data that does have a data structure, but it's not that complex as you see on some SDK. It's different design. So design is trying to break down the attributes, break down the control to the attribute level. So each attribute is really a small data that is independent with each other in order to, other than just provide a huge data for the ASIC to consume or read it back. So that's the first comment. The design philosophy is to break down the attributes as the smallest level. The second comment is that in terms of the query, we do have a bunch query APIs allows you to query a set of attributes, attribute for a set of objects, and also a list of attributes. The query API does have that batch operations.
The bunch API, you can send one query, get a bunch of data back.
Are there other questions? There's one in the back here.
Do we have batching capability with SAI? Let's say if I have 1,000 routes going over one single next hop, do I have to say route 1 next hop, route 2 next hop, route 3 next hop? I mean, does SAI allow you to say that, okay, these are my prefixes, and all of them are going over one next hop? So does SAI provide that capability?
I think the SAI does have a capability for adding the routes in a bunch, in a bulk API. But however, the only difference I see in the current version is that for each route, you still need to provide that next hop ID for that route. Although for the 1,000 routes, it's the same next hop ID, but you need to provide each route and next hop route. But you can provide them in the singles API.
So I mean, essentially, I see. I mean, when you have a lot of routes to program, you might have to duplicate a lot of things and send a message. So I mean.
Yeah, I think the more with current version we have doesn't have a bunch API. You can add 1,000 routes at one APIs. But I think you have to point in the routes to the next hop one by one. But it does in the one API. If that's the further optimizations we need, we can think about it.
We can take it offline.
Okay, thank you very much. We're out of time now.